G'day guys, how you going? So today what we're going to be looking at is more physics, looking at current in series and parallel circuits. And I wanted to start with a definition, right? Because current is the rate of flow of charged particles in a circuit. And what this means is it's effectively looking at how quickly electrons are moving in the circuit. If they're moving really quickly, that's a high current. If they're moving really slowly, that's a low current, okay? Just to refresh you here, a series circuit, there is only one path around the circuit. As you can see from this electron, it can only flow down one path, whereas in a parallel circuit there is more than one path around the circuit, i.e. the circuit splits somewhere. And you could see this electron could go around path A like it just did, or it could go down path B like you see just there. Okay, there is more than one path the electron could take through the circuit. So in a series circuit, current will not split because there is only ever one path. It will be the same no matter where you measure it with an ammeter, okay? Whereas in a parallel circuit, current is split because there's more than one path, and it will be at different locations depending on how you measure it. We're going to have a look at both current in series and parallel circuits using a FET simulator, which is a really great resource, and I'll pop it in the description below so you can see a link to this and you can build your own circuits. So here we are at a simple series circuit. You can see the current, which is how quickly these electrons are moving. And just eyeballing that, you can see that they're moving fairly slowly and they're moving at about the same speed all the way through. But we can actually use an ammeter over here to measure that. So its current here is 0.9 amps, current there is 0.9, current here is 0.9, here is 0.9, here is 0.9, here is 0.9. No matter where I measure it, you'll see that current is the same. And that's because there is only one path for electrons to flow. Current is not split, okay? Let's have a look at a parallel circuit then. And straight away, you'll be able to see parallel where there's a split. But if you just eyeball these electrons, you'll see that they're moving a little bit faster here than they are in either of these two circuits just here. So when they're inside the parallel circuit, it seems like they're moving a little bit slower, which is a bit strange. Now, the reason why is watch these electrons, and you'll see that one goes one way, one goes the other way, because current is being split, much like a river being divided into two, right? The same thing is happening to these electrons. Some electrons will go down path 1, the other electrons will go down path 2. So let's quickly measure the current and have a look at that. Current in this part, or the main part of the river, is at 1.8 amps. After that current has split, it actually goes down to 0.9 amps, or half the speed, right? And if we go to the other one, it is also 0.9 amps, which is half the speed as well. So it's slowing down when it moves into this parallel circuit, when current gets split. And in this case, current is being split in half. Half goes down path A, the other half goes down path B. Okay, and if we add those two back together, which is what's happening here, you can see those two currents or two streams are recombining, and the electrons are speeding back up, back to 1.8 amps. Okay, and that's literally series current in series and parallel circuits. So just to refresh, in series, current will not split. In a parallel circuit, current is split as you move through it. Okay, guys, hope this helps.